Hey, welcome back, and we continue with lists because you know how much fun these things are. Okay, so unfortunately now we've got this slightly more complicated thing called nested lists. Okay, well, basically it's a list inside a list, but of course the programming will probably obviously be a little bit different. Okay. The very first thing that I realized earlier when I brought this up is I said, okay, good. I've got like one of these Kahoots, and one of the Kahoots, the first thing that I bumped into is this list.sort because I never covered in a previous lecture. So I'm doing this mostly for the Kahoot later on. It's a pretty simple concept, but really it probably needs to be covered in the previous slide. Okay, so let me take just 2 minutes to demonstrate what I mean by sorting. It's not a difficult concept. Okay, suppose you had a bunch of test scores as an array. Okay, so a 78, a 69, a 45, a 98, a 50, a 12. Let's see, pick some higher scores here. All right, perfect. So there we go. Obviously, I could ask what's the biggest score, and everybody will say, yeah, it's 96. It has, or sorry, 98. And we already know how to find that because there's a function built in called max. Okay, good. If I ask you what's the second biggest score,
56.
Okay, now that's a little bit trickier. Okay, what you could do is you could find the biggest score, that would give you the 98, then you could remove it, and then you can find the biggest score what's left, and that would be the second biggest score. Okay, that's one approach. In fact, I kind of encourage you that you actually try this. All right, but there's an alternative way which can be really, really helpful, and that is to use something called sort. And we're going to cover a whole bunch of stuff on sort later, so the only reason I'm covering this now is because I've got a Kahoot question that happens to involve the sort. Oh, I'm sorry, test scores. Doesn't work if you don't spell it correctly. All right, pretty tricky business, right? Yeah, it takes all the scores and it puts them in order from smallest to biggest. So now if you're looking for the third biggest score, it's pretty simple. All you do is you take a look at test scores at position -3. Okay? And you don't have to like remove anything because what you've done is you've actually reorganized everything so that it's in increasing order. Just one quick thing about this because you know there's always going to be tricks about these things. So here we go. If you try to put anything in as a string, that will blow up because they all have to be integers. Okay, otherwise it doesn't work. But you could put them this way, except that you do run a really bizarre risk that when you sort this, it's going to sort lexicographically, like the same thing when we talked about the maximum and so on. It'll find the thing with the highest ASCII value. So just when you're sorting a list full of strings, you can get something a little bit strange. Okay, but it's a list of strings just sorted alphabetically. And just in this case, the 9 happens to be like the absolute biggest, even though it's actually kind of the smallest. Okay, if you really want it to be sorted so that things show up at the beginning, what you'd have to do is you'd have to convert all of these strings into an integer, sort, and then convert them back to a string if you really wanted that. Okay, so pretty straightforward. It's not really part of today's lecture. It was just one of these things that I realized I suddenly forgot, so we'll just include it, and now it's here. We will come back and we will talk a lot about sorting much later. Okay, so take a look at the piece of data that I've got right here, okay? Yeah, I've got a lot of pieces of data. I've got a whole bunch of years, 2020, 520, 480, 450, 500, etc. It's sales data for a bunch of different years in a bunch of different offices. Okay, and what I'm interested in doing today is figuring out a way how we can save this information. Now, I'm going to propose something today. I really don't think it's the greatest solution, but it happens to solve our problem, which introduces the concept of a nested list. So it's not really what I want to do. This is not the way how I would store it, but this is a way how I could store it. Okay, so we've got a whole bunch of different ways how we can store this information, and then of course do things with it. Like for example, I might want to know, hey, tell me the sales for the West Office in 2023. Okay. From this table, it's pretty easy. West Office 2023, it's 550. I don't know what that is, maybe millions or thousands, whatever it happens to be. It's 550. Okay, maybe I would want to know how much, what the total sales were for all the offices in 2023. This would be another interesting query. So I've got a bunch of data. and I'm talking just by hand, how would you do it? You would go across and you'd add up the 590, the 530, the 510, the 550, add them together, perfect, everything is done. Okay, and I might also be looking for one particular office all the years. So we might be talking about going through a column of these things. Now, the issue is we haven't seen anything at all that looks like a table, because if I asked you, especially for those coming from, say, the fintech world, you would definitely be using Excel for things like this, right? And of course, you know, it makes sense to be able to add up rows and columns. But we haven't seen anything like this so far, because all that we have is something called a list. That's the most complicated data structure that we've got. I suppose we could keep 25 separate variables. Nobody wants to do that. So we're talking about storing this into a single list. Can we do it? And the answer is, yeah, we can obviously do it. So here's what I'm going to do is I've got a bunch of proposals here, and we'll try solving a couple of these problems, and we'll just look and see what types of issues we're going to have and whether or not we can come up with something that's decent. All of these, by the way, are sort of really bad implementations. Eventually, we'll get something pretty decent. Okay, here's the first thing that I'm going to do. All right, there you go. There's the sales amounts. Okay, and yeah, obviously, if I print sales, bang, there you go. That's the sales, and I'm going to ask, are those the sales numbers? And the answer is, yeah, those are exactly the sales numbers. I mean, I've got the 520, I've got the 480, the 450, the 500, the 540, the 495. Yeah, I've got all of this stuff. All of the data has been put in here, and I've got it in one really long array, one really long list. And it will make certain things pretty decent. Like, for example, if I wanted to add up all of these numbers, is it easy? And the answer is, yeah, it is. All you need is, sum. Okay, it's sum. You pass it as a function. There you go. There's a total of everything. Excellent. That answers answers a question. Let's just add up everything. I want total sales for all the years. That's trivial. Okay, now on the other hand, if I wanted to sum up, say, just one particular item. Okay, well, let's start asking for this. So here we go. Without going back and showing you the other picture, let's write this. Print, that's the word print when your fingers are in the wrong place. Here we go. Try it again. Print the sales for 2023 East office. Okay, the answer's up here. But nobody knows where, right? Yeah. Okay, well, here's a hint. It's going to be sales at a certain location, okay? The location is 14. Okay, was it really? Okay, well, maybe I've messed something up. Let's just take a look at it. Here was the sales. All right, remember, East Office 2023. East Office 2023 was 510. Yeah, 510. We did it. Okay. However, I hope that you realize that where did I get the number 14 from? Well, basically what I did was I cheated and I counted. Okay, and it was written right here. That's the only reason why I knew. All right, you didn't know because you didn't have the table in front of you. All right, so if you don't have the table, then it's going to be really difficult to figure this out. That's one of the downsides of this approach. Okay, and by the way, what we're going to solve is not a whole lot better, but it's going to be, I'm going to call it slightly better. Okay, so eventually we will get to something slightly better. Now, if I was looking to say, and of course that's the sales for one particular thing, print a Selxy, okay, well the sales. All right, let's change up the problem a little bit. This one isn't here. How about for this, 2023, all offices. Ooh, wait a minute, all offices. Okay, remember the way how we stored this is, and by the way, I've been very nice and I pressed enter on each line. And if I didn't do that, you wouldn't have any idea where anything was. Yeah. All right, so what this is 2020, this is 2021, this is 2022, this is 2023. Yep. Okay, let's see if we can extract something down to a little tiny bit. Remember our wonderful business of list slicing. Because remember, if we do something like this, it's going to give me like part of a list. All right, so if we were looking for exactly this stuff right here, we're talking about taking position number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's from 12, not from 3, but from 12 until 16. There you go. So I've been able to magically kind of pull something out. Okay, so here you go. That's the 590, the 5. Oh, by 4 each time, right? It's kind of a hint, but it has more to do with the way how the mechanics of how things are stored. And at this point, I just need to put it inside a sum, and I'll be able to get this. Okay, that's all right. All right, so good. So we've got a technique. Other than, this is a real pain in the neck because I don't know exactly where. I can show you a formula for doing it. Sorry, it isn't here, but I can show you a formula for it. Okay, take a look at this. Year is 2023. Okay, where do I start? Well, what I could do is I'm just going to call it start 12 and end equals 16. Sorry, I'll fix that in a second. I'll say from from start to end. Now, the question is, how do I get 12 out of this? Okay, the very first year I have is 2020. So what I'm going to do is I'm going to subtract 2020. Okay, and then what I'm going to do is I'm going to do something, it's this one right here. Sorry. What I'm going to do is instead of putting this as 12, I'm going to take the year and I'm going to subtract 2020, and I'm going to multiply the entire thing by 4. Wait a minute, where did this come from? And what I'm going to do is the end is going to be the start plus 4. This will actually do it. Okay, now, there you go. There's 2023. Let me show you the 2021 sales data. 540, 494, 470. It's the second row. If you wanted the very first row, yeah, that's 2020. Oops, then this way, 2020. All right, there you go. There's the first row. Pretty neat, right? No, nobody likes it, right? Okay, why? Because that formula came out of absolutely nowhere. Yeah, I completely agreed. This would be a terrible way to work. Okay, absolutely, this would be a horrible way to work. You can make it work if you can observe patterns and multiples and its modulo stuff. This is all very, very simple, so you can do it. Hey, modulo, that might be kind of cool. Okay, but it's not very much fun. Okay, and I promise there's going to be a better way. Let's do something else that's absolutely crazy. Let's suppose we wanted to total up the columns. Okay, let's suppose I want the total of all the offices, all the West office sales. Okay, there's no easy range. There's no easy slicing that I can do because it's one spot, there's the next spot, the next spot, the next spot. But the one thing I can guarantee, take a look at this. Where are they kept? Okay, take a look at the positions. That's position 0, that's position 1, that's position 2, this is position 3. Okay, this one right here is at position
7.
It'll be 6. Oh, 0. Okay, here we go. 0, 1, 2, 3, 4, 5, 6. Oh, it's 7. Okay. 8, 9, 10, 11. Okay. Now, 7, 3, etc., etc. They actually have something in common, but again, it has to do with can you observe the pattern? So, hey, back to our 1101 stuff. Here's what I'm going to do. Okay, I'm going to do something really strange. Again, this is not going to become on a test. I just want to explain why this is not going to work and what we're going to do instead. Okay, for index in range, length of sales. Okay, if I print sales at index right now and I run this, what do I see? Everything, absolutely everything. I'm going to put an if statement. Okay, watch this. If index, oh, what is this doing? I'm dividing by 4, I'm looking at the remainder. If that's ever equal to 3, what am I seeing? Exactly the very last column. Okay, so if you're wondering, hey, what's the point of a modulo operator? It's for doing things like this. Okay, all right. Again, cool. Well, maybe, but most people don't like it because it requires a bunch of thinking in terms of math. It's a problem solving. It's looking for patterns. Yeah, this is really what program is about, is looking for patterns and things like this. Can we do something a little bit better? And the answer is Yes, we can. Okay, and what I'm going to do is we're now going to reformat this to make it a whole lot easier, because this type of approach is not really working well for us. It can be done, it's just not very nice. Okay, so here we go. Let me erase this. I'm going to ask a question. What can you put into a list? Anything you want. You can put in integers, you can put in strings, you can put in a mixture of integers and strings and booleans. We did all of this last week. And one of the things that you can also toss into a list is a list. Okay, so give me a second while I type in a bunch of square brackets. Okay, that's the end of that list, end of that list, end of that list, and end of that list. Okay, so what we're going to do, we're going to print sales. Remember, when you print it, it has no idea how to format it, just prints it across one big long line. Okay, but this data has now been slightly better structured, because within every set of brackets, that's exactly 1 year. Okay, and that's really kind of important. So every one of these brackets from here to here, which is a list inside the list, that happens to represent the sales for exactly 1 year. The very first item inside each one of these smaller lists is exactly the items for one of the offices. I forget which one I put first. I put the North office first. Okay, so it's always at that exact position. Now, what we can do in order to access these things is I can start to use the square brackets to extract things. Because remember, when you use a square bracket and you provide an index, you're pulling out exactly one item. So if I print sales, I will see absolutely everything. If I print sales at position 0, it's only going to show me one thing, but the one thing is a list. And you see what you've got is you've got exactly this. That happens to be the sales information for 2020. If you want the sales information for 2022, okay, all you need to do is add 2 to that. Okay, and there you go. There's the sales information for 2022. So you're pulling out all this information. That is so much easier than the list slicing and having to multiply by 4 to figure out, when does it start, what does it end. Okay, this really is considerably easier. All right, but what if I'm looking for one particular thing? Like, for example, if I'm looking for the West office. Well, we know that the West office always appears in the very last column. So this one right here gives me all of the data for 2022, but if I'm looking for just the West office, it would be the stuff that's at position number 3. Okay, and this allows me to drill down to exactly one of these items. Okay, so I can go through and I can pull up exactly one item by using 2 square brackets. The first square bracket to give me essentially the row, the second to give me the column within that row. Okay.
So confused what happened after the end of this list.
So what is this? See, that's a full list.
Yeah.
Okay, if I'm looking for one of the items inside the list, this would give me the very first item. This would give me 565 because it's the first item inside that smaller list. It's called a sublist.
Okay.
All right, congratulations. What this is called a nested list. It's lists inside another list. Okay. All right, now this is one of the reasons sometimes you have data that looks like tables. This is exactly what you'd end up doing with it. Yeah. Oh, sorry, which section?
The West office, the whole amount of West.
Oh, the whole amount. Oh, okay. It's like, okay, a lot of stuff in the world of programming, it makes one thing easier and it makes other things more difficult. Okay, and sorry, sometimes this happens. I'd like to come back to that. Okay, let's do the other ones first, and then we will come back and we'll add everything up, which I think is what you're looking for. Okay, and that's certainly fair. It makes some things easy. For example, let's see, we'll put this up. So what does sales at position 2 represent? All the 2022 stuff. Okay, if I wanted to add up all of that stuff, no problem, it's sum of all of the stuff. There you go, that's pretty simple. All right, now what about adding up a column of information? I mean, we did this already, and we had to use modulo. We had to check and see if it was evenly divisible by 3, at which point then we decided to include it. Okay, you do pretty much the same thing. Okay, but, okay, there's going to be a couple of things in here. So we'll build this up slowly, then we'll come back and we'll talk about adding it all up. Okay, for loops. Okay, hey, how about this? You know what happens when I put out an X? It just means I'm not sure what to call it yet. You don't get to use X. I don't get to use X. I just get to use it right now until we figure out what it is. Okay? In sales, because it is a list, so therefore we can do it. And if we print X, what do you think we see?
For X and sales.
Well, how many lists? Okay, this is kind of a tricky question. All right, we've got this list called sales. How many things are inside sales? Okay, I know there's a lot, but there's a number in here. And the number that I'm looking for today is 5. There are 5 lists.
Yeah.
Okay, this, when you say for X in sales, it's going to iterate for each one of those lists. And yes, there will be 5 things that are printed out.
Okay.
Okay, so there we go. So what would you call this? Well, I would probably call this year sales. Okay, because that's really what it is. It's sales for 1 year. I don't know what year it is. Okay, we'll come up with ways of solving that problem, but I need a couple of weeks yet. Okay, I promise we'll come back and we'll fix this one because it could be much, much better. Okay, so there we go. We'll just call it year sales. All right, if I wanted to, I could print out, say, disposition number 3. All right, what would this give me? It would give me all the sales for, well, just to remind you, okay, it'll provide me all of the sales for what part? Okay, so remember, year sales, that'll be each row, and I'm going to go and I'm going to look in position number 3. What are the values that we're going to see? Yeah, okay, 500. 590? No. I don't know, it sounds like you're guessing. Okay. Yeah, let's run it so we can take a look at it. Okay, maybe you were saying it, I didn't quite hear it. Yeah, it's exactly a column. Yeah, it's exact. So for every row, I pulled out exactly 1 column, and I pulled out the thing that was in column number 3. That's a lot easier than doing a modulo 4 and finding out if it's a remainder is equal to 3. Yeah, much, much easier. If I was looking for, say, the, where's my picture? All right, suppose I was looking for the South Office. What would I type in here to see all the sales for South Office? That's the, yeah, it's column number 1. Okay, so North Office comes as column 0. This comes as column number 1. Okay, here we go, and bang. There's exactly the South Office. Unfortunately, it means that you have to know that the South Office is in this column, the North Office is, okay, we'll eventually solve that problem, but I can't do it today. Okay, but we will solve that problem. I could solve it using all kinds of other weird things, but it's something we're going to solve later using dictionaries. So please wait, and difficult things like dictionaries we'll make this easier. No, that doesn't sound good. Actually, although a lot of students do say, no, these dictionaries are very difficult, actually they help you solve problems like this. All right, what if I wanted to have like all of these things added together? Fine, you know the summation pattern. Okay, so we want a total. You would have a total, and you'd say equal to 0. Here you'd say total goes up by year sales at position 1. And then at the very end, you'd print total. There you go. That's the total for that office. Okay, for across all the years. And you might say, can I use a sum? Because I really like sum functions. Okay, you can do it, and I might as well show you how to do it. But this is what you need to do. A sum only works if you have a list with actual integers. So let me demonstrate something first. Okay, because there was a question, what if I wanted to sum absolutely everything? Okay, this, by the way, is not going to work. Why? Well, because it's not a list of integers, it's not a list of floats, it's a list of lists. And if you try this, that's exactly the problem. It says I can't combine an int and a list. The int is because it started with the total equal to 0, and then it tried to put the list on. Sorry, you can't do this. Okay, so unfortunately, you can't solve this one. But if you have just a simple list, it's pretty straightforward. So here's what I'm going to do. Okay, year sales. Okay, we have office. Just to give you an idea, I have an array here called office, and I'm going to go through, and each time I'm going to say office dot append. You've seen me do stuff like this before, and I'm going to print office. All right, remember when I printed it, we saw exactly column number 1. What am I doing with it this time? I'm sticking it into a list instead. There you go, there's the list. And what that is, that's all the column values, but stuffed into a list. Oh, if I have everything in a oh, by the way, this is a simple list. There you go. Now I can add it up this way. So if you really want to use a sum, stick it into a list and then use sum. Would anybody ever do that? No. If the whole purpose was only to get the total, I'd probably do the first approach, but this is certainly possible. And sometimes it might be a little bit easier. Okay, so what have we, and we're supposed to do a sum of everything, okay, because we've already realized that summing absolutely everything, it's not going to work. Okay, well, here's what we're going to do. Let's have a total equal to 0. Okay, I'm going to do this first. I'm going to say sum year sales. The way that I'm writing this code, by the way, is exactly the way that I will be teaching you all the way through. Notice that I never solve one problem by just writing a bunch of code and hoping for the best. I do little things to see what we've got. Okay, what does this print? We've seen it before. Yeah, all of the lists individually, one at a time. Okay, and that's for each year. Okay, let's change this up a little bit. Could I stick a sum in front of this? And the answer is yes, I could, because they're all integers, so it'll work. What would it give me? It would give me the total for each year. And if you run it, well, now I've got a bunch of these values. That's the sum of each year. If I really wanted to sum everything together, then what I would need to do is I would say, well, take total is equal to total plus the sum of the sales year. And then finally at the end, I can print total, and that is finally what would give me the full thing. Okay, so what have I done? Yeah, the first version where I did everything in a single list, that was easy to sum everything, but hard to get at the individual pieces. Doing it this way, it's easy to get at the individual pieces, well, easier, but it was difficult to sum everything. So what approach do you pick? Well, when it comes to programming, you pick whatever is going to be the easiest for your problem. If you never have to sum everything, then probably leave it this way. If you're doing constant access and you want to sum together columns and rows, this way makes life a whole lot easier, but it's going to come at a cost where it's going to be a little bit more difficult to do the other thing. When it comes to programming in infs1201, I've got bad news for you. I usually just give you the data and say, you're stuck with it, now process it. And you have no choice. You have to pick whatever I've intended to do. Sometimes you might get one way, sometimes you might get a different way. Okay, let's get back over to the slides now and make sure I haven't missed anything. And we'll see how things are going. And if I've missed something, then we can stop. That's the one I'm looking for. All right, so as I said here, yeah, you could keep it as 25 variables. And of course, notice that I'm not storing the year or the office locations. I could do that, and it will make my life even more difficult. It's a cool idea. We'll do this for 10 now. Actually, I might, because sometimes I have done this. All right, so there we go. One approach is basically to store everything in a single long list. Okay, that's fine. Me pressing enter, that was really just me trying to make it look a little bit better. But as far as Python's concerned, it's just one big long list. This particular example, this is usually called a flat list. You have a bunch of data, and it appears in just a flat structure. It makes it very easy for finding minimums, maximums, summing things together, but it doesn't make it very convenient for adding up rows or columns because there's no concept of rows or columns. It can be done. It just means you might have to use some weird math to do it. All right, so a nested list, on the other hand, is basically a list where every element is yet another list. And we use this all the time to represent rows and columns of two-dimensional data. Could you have a list inside a list inside a list? And the answer is yes, you can actually do this. That would be three-dimensional data. And if you had a list inside a list inside a list inside a list, that would be four-dimensional data, but it's a little tricky to draw. Is it not possible? And yes, you can actually continue on. So do people ever do this? No. Although it's feasible, and it's technically feasible, in this course I promise you'll never see anything beyond a two-dimensional list. I don't see any reason for it. In fact, if anything that you're ever dealing with for me, I would never store anything in something bigger than a two-dimensional list. That's really useful. It's just uh, for dealing with tabular data. Now, you'll notice something kind of weird has happened down here. I've got two lists as an example. On the left-hand side, I've got a rectangular nested list. And in that rectangular nested list, everything is very proper. Every row has exactly 4 things. Okay, that makes a lot of sense. It makes your programming really, really easy. It's also possible to have something called a ragged nested list where the lists inside have different lengths. For example, on the right-hand side, you can see the first year only had 3. The next year had 4. The next year had 3. Sorry, I see there's a square bracket missing. So pretend that that's a square bracket. The next one has 4, and the next one has 2. That's allowed from the world of Python. Unfortunately, it doesn't really make it very clear what it is. Because if I were to ask you, okay, based on what you remember, does anybody remember what this number right here represents?
500.
This was, okay, I know it's 500, but remember it was one of the years. Anybody remember? 2020, right? 2020, 2021. I don't even care which number it is. And it was from one of the offices. I think the last one was the East office. Okay, West office, doesn't even matter. Over here, okay, is that north, south, east, and does that mean that there's no west? Or does it mean that there's no north? And this is south, east, and west. See, you can't tell. Okay, all I know is that there's less number. I can still add it up. I can add up all the sales. That's not a problem. I can figure out each year how much sales were, but I can't go and I can't ask questions like how much sales did the West office have, because I don't know what piece of data it is. This is a downside to a ragged list. It's possible in the world of Python to do this, and it will work perfectly fine till you start using square brackets to pull things out. So let me show you what we can and can't do. Okay. Oh, sorry. Clicking in the wrong spot. So here we go. Here is a ragged list. Okay. We have different numbers of data. Does my program right now still work? And what does my program do? It adds up all the sales for all the years. Does it still continue to work? And the answer is, yeah, that works perfectly fine. Because a sum, it doesn't matter if there's 1 item in a list or 1,000 items in a list, it still works exactly the same. What if I ask for this? This would also be allowed. What it will do is it will, in fact, I don't even need sum at this point. Kind of silly, sorry, let's get rid of that. What this would do is it would extract the very first element of every list and it would produce a sum. Now, what does it mean? I don't know, okay? But here's something that's going to be a real trouble. If I ask for column number 3, you see the very first row, no problem. The second row, that's a problem. In fact, what's going to happen is the entire thing is going to blow up because when I try to get year sales, it basically doesn't exist. So year sales, let me print it just before. You see the very first row, no problem. That's why the program continued. The second row, I tried to access position number 3, but position number 3 didn't exist, and everything came to a screeching halt. Okay, so this is one of the downsides to dealing with ragged lists. Sometimes you have data like this, but it's not really good for representing tabular data. Okay, and my claim is really that's really one of the more important things. If you have just a bunch of data, you're looking for the minimum, the biggest, the sum, yeah, it's no problem. It does work, and sometimes I use this. Like, for example, maybe I've got test scores in different sections, and every section has different number of students. It works really well. I can calculate averages. I can calculate averages of everything. I can find the biggest and smallest in each section, but I can't ask the person at the very end what was their score because it'll be a different thing. I suppose I could use -1 to represent that. Okay, so it's a bit of a downside to this. So consistent sizes are definitely much easier to work with. Okay, and that's definitely true. In fact, it's so true that I would say if anybody ever gives you some data that's in a non-rectangular format, slap them and tell them to give it to you in a rectangular format. Or if it doesn't matter, well then it's fine. But don't take data like this and try to analyze the column position meanings. Yeah.
Could you
you put zeros to fill in the blanks?
There you go. There's the hack. Okay, yeah, fill in the blanks. So the question is, where does the blank go? Okay, so and you're absolutely right. That would make my life easier, but the question is where do I put the zero? Do I put the zero at the end? This spot, or the first spot? But if the person gave you the data and put the zero, then it would make a whole lot of sense. Okay, in that point, you're turning it into a rectangular list. Okay, very good. That's exactly what we do. Okay, to get an individual items, you need 2 indexes. So I think sometimes this is what makes students say that, oh, this is kind of tougher because I'm having a hard enough time just learning how to deal with a single index, and now suddenly somebody's throwing something in for a second time. Yeah, no issue. You just have to remember that the first little piece, data 1, that's a row. Okay, and then what comes next is the individual column. Some systems allow you to do something a little bit different. This is not a Python thing. This is just a warning in case you ever see another language. Some systems do things like this. Okay, you'd put a comma and you'd say, okay, I want row number 2, column number 3. Doesn't work in Python. Okay, so no, don't do this in Python. Okay, let me go back because I want to collect this data once again to kind of talk about the next slide. Okay. Let me type it. I won't type all of it, but I'll type some of it. Okay, that'll be fine. Let's see, 480, 510, 30, 550. I should have put this directly into the slides. Okay, you know what? I'm going to type it all. It's not that many, because I'm almost finished. Okay, and finally, 500, 515, 530, 550, and 570. Okay, there you go. And there's the same data again. Okay, but I've done a little bit different. Okay, so let's bring up the data so you can see it, and my array, or sorry, my list in Python. Okay, same data. And if I've missed something, then I'll fix it. Okay, it wasn't meant to be a trick question. Is it the same data?
Yeah, it is.
Yeah, but I've stored it in a different way.
Yeah.
Yeah, instead of going across on each row and putting each row into a list, I went through each column and I put each column into a list. All right, what would I get from this? It means that I could quickly add up columns, but it would be more trouble to add up rows.
Yeah.
Okay, so what this is, where did my slides go? Because I know I've got a slide in here next. Oh, sorry, I guess that's it.
So, what
Yeah.
if we made 2 variables and then stored the lists like variable, column and then row and the separate?
Oh, you're going to store them into, yeah, you could have 2. Okay, that would make it easier for both. But then if you ever update something, you'll have to update 2 of them. Yeah.
How to let the user input items with the nested list?
Ooh, okay, all right, give me a second. Let me get this out of the way, then I don't know what's coming on the slide afterwards. Okay, maybe it answers the question. Otherwise, we'll have the user type things in. Okay, and that's probably a good one. All right, don't worry, there won't be questions about this. But I think for completion, I wanted to include it. The first time, what I did was I stored everything 1 row at a time. The second time, I basically stored the information a column at a time. There's actually terms, they're called row major versus column major. I'm including it here because you might find in the textbook where they talk about it. In the world of Python, everybody always uses row major format. But some languages might actually store things in a different format. Generally, you don't have to worry about it. They will continue to work the same way you're expecting. But hey, just to let you know, you could add things up by columns, or sorry, you could store it by columns first, or you could store it by rows. Okay, so don't worry, no question about this one. All right, iterating values in a nested list. Oh, okay. So let's start. We'll pretend that this is now my data, or should I go back to the other one? Let me go back to the other one. I've got it stored, and I can copy paste. Okay, the first piece is pretty straightforward, And the second thing, get forward. Okay, iterating element based, okay, index two-dimensional list. Okay, I'm gonna iterate first, and then we're gonna input these things, and we're gonna ask the user to type all these values. Ugh. Okay, we'll do this afterwards. Okay, let's try printing all of the values. Okay, well, here we go. We've kind of already done this. We said for year in sales, print year. Okay. Oh, that's the wrong format. Okay, so what type of list is this? That's got a name. I showed it a few minutes ago. Is that a nested list? No, what's it called?
Flat list?
Yeah, it's a flat list. Okay, sorry, that was not my intention. There we go. I meant to grab this one instead. All right, here we go. So pretend you didn't see that. Okay, but it was a good chance to double checking things. All right, so here you go. Can I see all the values? And the answer is yes, I can. But of course, every print statement, what I'm doing is I'm seeing a full list. If I wanted to print each one of these items separately, well, remember, each one of these things is a list. So what I could do is I could go through each of the amounts in year and print the amount, except amounts. Actually, I think amount would make more sense because it's one. There you go. There's all the individual things. Okay. Oh, hey, what can we do with this? Well, we can obviously print it. Here's something that's kind of cool. How about this? Let me just call this temp. Make it an empty list. Instead of printing it, what if I said temp.append amount, and then I print temp at the end? What do I get? I get one list, and it is a flat list. So there you go. There's a way how to convert a nested list into a flat list. That, by the way, has been a question before on the lab exam a couple of years ago. It won't come back now because I just showed you, but that was a question at the time. Okay, how to convert this piece of data into a flat list, and we provided the examples. And yeah, what it requires two loops, a loop inside a loop, because well, we have data. Remember, one loop to unpack the individual lists, and then one loop to unpack each individual sublist. Okay, and yeah, we just collected these things instead of printing them. All right, let's go back to printing them again. So here we go, print amount. I'm going to show you some things that are very, very useful. Like, for example, here we go. This is a year. This is a new year. There you go. So this is a new year. Here's the next data. Here's the new year. Here's the next data. So if you wanted to process some data and do something every new year, you wanted to reset some kind of a counter, fine, you could do this type of thing. Okay, so you can put print state, or you can put stuff before dealing with the individual loop, or sorry, the inner loop, and as a result, you can basically process one row at a time. Okay, that's one approach for for pulling these values out. And then I've got this horrible thing where somebody's asked me to ask the user for things. Ew. Okay, well, this will be very important to be able to print it. Okay, so we will do something like this when we want to see what we've got. But I would like to show you a slightly different way of also iterating through. Because remember, there was always two ways. Remember, I could do this, or I could do this. I could say for index in range length of data, and then print out these individual items. Okay, so two ways. You can either use the for loop to go for in, or you can use a range and an index. When do you use one? When do you use the other? Whenever it's convenient. Okay, I will never come in and say you must use this type of a loop to solve this problem. Instead, you use whatever's required. You use the index when you need to know the position. You use the for in when you don't care about the position, you're just looking for the values. Until we have an actual problem, we're not going to be able to save this. But do we have indexes in multi-dimensional lists or nested lists? And the answer is yes. Here's what you do. Okay, I will often use I for this. Most people will use I for it as well. We'll say for I in range, length of sales. Print I. Now, I'm going to run this because we better know how many times this loop is going to happen. When I run this, what are we going to see as the output? Here's a hint. It starts with 0. 0 to 3, are you sure 3? Yeah, 4, okay. I believe that one. Why do you think it goes only up to 4?
Only
Because how many things are inside sales? There are 5 things inside sales. They're each lists, and that's exactly it. Okay? All right. Now, here's what we're going to do next. There we go. We'll notice to talk about the rows. All right, here's what we're going to do next. I, of course, got a whole bunch of columns inside. I'm going to have a second one for j in range, length of, I don't know. We'll get to that in a second. Every row has how many sales? 4. It's hard-coded to 4. We'll get to that in a second. Print j. Take a look at what happens when I run this. When row is equal to 0, I get 0, 1, 2, 3. When row is equal to 1, I get 0, 1, 2, 3. When row is equal to 2, I get 0, 1, 2, 3. This is providing 2 coordinates. It provides an x coordinate, basically a row number, and a column number. So here we go. Let me print this, and we'll say call j. Okay, so here we go. So row 0, and then call 0, call 1, call 2, call 3, and then row 1, call 0, call 2. Yeah, I'm able to see all of these values. Now, if you really want to see the individual values, well, then all that I need to do is to go back to the sales, and I can say, give me row I and column j. Okay, and what we're doing is we're now iterating through, and we're using these 2 indexes to pick off the individual values. Okay, there's a second way of printing these things out. So what we'll do is let me get rid of this column and probably make the data a little bit easier. So here you go, here's row 0, and here are the individual things. That's kind of the classic way for going through and pulling out individual things. You have a nested list, a nested loop with an I and a j, the I being a row and j being a column. Sometimes I'll call this row and I'll call them column just to make it much, much clearer about what's going on. Now, I don't like this hard-coded value because this is not going to capture everything. Okay, for example, if I do this, that's going to cause a problem because when I try running this, it's going to blow up because the index is out of range because I've gone too far. I shouldn't have gone to 4, I should have only gone to 3 for this one row. So what I'm going to do is I'm going to go for the length of, not I, but the sales at position I. The length of the row at position I. Okay, now this will end up working the way that we want. Okay, yeah, that one's a little trickier. I think I prefer the other way. 2 nested for in loops, yeah, it works really well. Unfortunately, sometimes you need to know the positions, the row and the column number, because you're trying to update something at a certain location, and you might have to do these. Okay, all right, now we have to go back and we have to look at that horrible thing where somebody asks, can we ask the user for this information? I'm really unimpressed that you did this to me. All right, but no, it's okay. It's a fair question. All right, let's ask the user for some sales. Let's try to do this. Let's try to reduce our problem so that there's only 2 years. Okay, it'll make my life a little bit easier, and extending it to more years is not a big problem. 2 years, but 4 offices. Okay, and we'll collect the data. Okay, that's a pretty reasonable thing. So to begin with, I know nothing. Okay, that's pretty reasonable. So here's what I'm going to do. For year in range, year in range, 2021, 2023. All right, before we start writing any code, what am I going to see when I run it? You know how to deal with for loops. There will be tracing questions. Okay, what are we going to see? Yeah, 2021, 2022. There you go. So those are the 2 years. The reason why I'm doing this is because I am going to say this. Enter sales for year. Okay, I'm going to do this. No, of course, that's not actually asking. I'm now going to have to go in. Now, how many things do I need to ask for each year? Unfortunately, 4 things. Okay, so here's what I'm going to do. For office in range, we'll fix this in a few seconds. For office in range 4, okay, sales is equal to int input enter amount. For what? I don't know. We'll get back to that in a second. All right, let's find out. How are we doing? Enter amount. Okay, here you go. Here's an amount, here's an amount, here's an amount. That's 4 of them. Here is 4 more, and I'm finished. Okay, so the skeleton of the program is working. What do we want to do with the sales? Okay, now, unfortunately, I shouldn't be using sales because I've already used it, so we'll call it amount. All right, what do we do with this? All right, first one, sales, append, amount, print sales. Okay, here we go. Small numbers, just so I can type. Let me type just digits. Okay, does this do what I want? Well, maybe, but take a look what the result is. Everything is in a flat list, okay? Because all that I did was I just kept appending onto the end. Okay, I mean, it kind of works, but it maybe you wanted this in a nested list instead. All right, if I wanted to stick this into a nested list instead, sorry, it's a little bit more involved. It's not impossible, but it is a little bit more involved. What I would normally do is I would have an extra variable called maybe year sales, which is a list. I'll start the list off as empty, and what I'm going to do is I'm going to append year sales, the amount. Now, obviously, if I run this, you see, every time that I finished up a year, I had a list with exactly the 4 things. But the thing is, I never put it inside the actual sales. If I wanted to store it inside sales, after I finish collecting all the data, I would say sales.append year sales. Because remember, each one of these things happens to be a list. So here you go. Here's 1, 2, 3, and 4, and 7, 2, 2, and here you go. So I built up the list this way. I built up a small list by making it equal to an empty list. I repeated 4 times, and once I was finished, I appended it on to the end. That's the way how you build up nested lists. Okay, it's just a matter of updating things. Now, I know what you're going to say is, wouldn't it be really cool if it said enter amount for north office, south office, east office? Okay, we can do this. It's not in the slides, but that's fine. Hey. Okay, for office in, square brackets, yeah, okay, here we go. North, south, east, west, okay. Enter amount for office. There you go. How much for the north office? Okay, 56. South office, 12. East office, 60, 20. And we repeat again, the north office. Okay, small amounts. There you go. You want to make it a little bit better? Yeah, you can actually make up these little lists in here to do exactly what you want for printing out labels. Could we do the same for the year? Yeah, if you had a small range of years and only a couple of things, yeah, it works really well. Of course, the north, south, east, and west don't actually get stored in here. It was just for printing purposes. Okay, but hey, it's a cool idea. It kind of improved things quite a bit. All right, so I take that back. It was a good question. Thank you. We should go and add some extra stuff. Okay, so here we go. We've got 2 possibilities. So we can either iterate through using an element-based for loop. That's where we have the 2 for loops, both in, okay, and you'll notice that it's always the same format. It's for row in the table, and then for value in the row. Replace that with the actual problem domain. It's for the year sales, and it's for the amount or the office within the sales. Don't just use row and column. Use what they actually mean. The alternative is to use position-based things, I and J. Okay, this one here. Okay, I think I got a couple. I don't think I will run these unless we really think we need to. If I simply asked for length of data, that would tell me the number of rows. Hey, we did this a bunch of times. Okay, I won't run this back here. Oh, but all my data's gone. Okay, I take it back. I will run something. Let me put this back. Here we go. Print length of sales. All right, what number do I see? 5. And what does it represent? the number of years in my particular problem domain. Sales at 0 is also a list. It's the very first list. So if I run this, what am I going to see? 4, because that's how many items are in the first list. That's the number of offices in the first list. How many offices are in the second list? There's only 3. I don't know what they're called, but there's only 3 of them. Okay, there you go. That's what the slide means. Okay, so using length at 0 or length at position data position 0, how many items are in a particular row? Okay, and of course, for figuring out the size of a two-dimensional list, it only works if everything is the same size. If you want to make sure everything is the same size, you have to go through and you literally have to check the length of every item. Okay, I'll leave that one as an exercise for you so that we don't go too much longer. All right, there's a final thing in here, and that is flattening the list. Yeah, actually, we did this already. In fact, we built this up a couple of times. Okay, is it possible to take a flattened list and put it back into a rectangular? Yeah, sure. You know what? I will do that one. Okay, just so that we've seen it. That shouldn't take very long, so I need a flat list. Just so you have an idea about how to go about these. All right, if I wanted to turn this into a rectangular list, okay, I'll call it rectangular nested. All right, here we go, rectangular nested. Okay, so right now it doesn't do anything. The first thing that I would need to do is I would need to iterate through all the values. Okay, and watch this. For index in length, sorry, in range, length, sales, print index. All right, if I run this, I'm going to see a bunch of indexes. The first one will be 0. The last one, as soon as I, oh, sorry, len, sorry. It's the problem of teaching Node.js at the same time. All right, so we see the numbers from 0 to 18. So we know there's 19 elements in this list. All right, so we want to put this into some kind of a rectangular format. First of all, it's never going to fit because it wasn't rectangular in the first place. This one stands a chance. Okay, so this one actually will have the same number each time, so let's add one extra. If it doesn't, sorry, you have to look at the problem to understand how to solve it. All right, if I wanted to put this back so that we have 4 elements on a line, or sorry, 4 elements in each list, we've actually done this already. We just did it a second ago, but I'm going to use the index to do it. Here's what I'm going to do. What would be a good thing? I'm going to have this variable called temp. Instead of printing, I'm going to say temp.append, and we're going to put in sales at index. All right. Yeah, that's what temp looks like. It's got everything. That's not what I want. All right, here's what I'm going to do. I'm going to ask a question. If index modulo 4 is equal to 0, I'm going to go to the rectangular nested, and I'm going to append temp, and I'm going to set temp back equal to nothing again. So what happens is I keep building, and oh, actually, I don't think I want that. I think I want when it goes to 3. That's when I want this to actually be ejected. All right, so what I'm doing is I'm building up. I'll have nothing, then 1, then 2, then 3, and as soon as I hit 3, boop, I chop it into the rectangular nested, and I carry on. So there you go. There's the option. Okay. So in case you ever want to deal with this, yeah, you use the modulo operator, put it back together. Oh, nobody likes modulo operators. Yeah, it's fair game. Nobody likes them. Okay, yeah, they're more tricky. But this is actually what we use modulo operators for in programming all the time. When we're looking for repeated patterns of data, it works really well. Just out of curiosity, if I replace it with a 5, what would happen? I'll take a look at the result. Okay, so, sorry. Maybe I should put a 5 and we'll put a 4. I think that would probably make life a little bit easier. What happens? Well, I end up with 5 elements in each list before moving to the next one. Okay, so it's the repeating stuff over and over again. Okay, Again, have I ever asked somebody to do this? No. We've asked people to unfold lists, but pretty rare that I've ever put it back in to fold up a list. Okay. Asking the students to write code to prompt the user for a bunch of data to go in, maybe once on a lab. Would I do it on a test? Usually not, because usually what I will do is I will give a bunch of data and say, please transform it to do this. Like I might give a nested list and say, okay, add up these columns. Or figure out which column's got the highest sum. That's a pretty tricky question. Add up these individual rows, maybe transform it into a flat list. These are all sort of typical questions, but asking the user to type a bunch of numbers, no, because typing a bunch of numbers is, it's pretty dull. And it's sort of a bad use of test time because people are constantly typing in numbers. I'd rather you type code and type numbers. So usually we just give the data and say, here you go, you got to work with this and you need to do something with it. Count how many items are over 500, count how many items are less than 500. Count which office has the highest when this particular office is in the third column. These types of things. This is often what we end up asking. Okay, I think the good news is that might actually be it. Okay, all right, so nested lists, yeah, it can be a little tricky. Okay, yeah, they do take a little bit more work because now you've got a second thing and you often end up having to use two loops. The thing to keep in mind is when you're writing code like this, use lots of print statements to see what you've got. If you don't know what you've got, it's pretty hard to come up with indexes to actually access things. Just print them. When you're finished, remove the print statements. You see me do this all the time. Like for example, what I might do here is sometimes I could end up printing temp. Okay, and you can see that the temp starts off with one item, the 2 items, the 3 items, the 4 items, and 5 items, and suddenly goes back to 1 item again. See, that's very, very clear about what's going on. And if you're not sure what to do, or you're completely lost because something isn't working, just knowing what you've got in memory, it really does make a big difference. Also, naming things is very, very important. Quite often in the labs, I will have students, instead of calling this rectangular nested, they'll be lazy and they'll type A, and it just is not as clear about what it is. Okay, try to come up with names, and I know sometimes this is actually one of the harder things, is to come up with an appropriate name. Print what you've got, and then look at it. So if you set up a loop and you say for X in something, look at what's being printed, and then change the name X into something that actually makes more sense. Okay? It really will make your code easier to understand. And if you are in a lab and you called over the instructor saying, hey, what's wrong with this? At least they can look and they can say, well, maybe your sales amount is wrong. Print that out, as opposed to, what's X? Because we don't know. Okay. All right, so there you go. That's the stuff about nested lists. Okay, so as promised, or threatened, whichever it happens to be. Okay, we've got one of these little fun Kahoot things. It's the second list item, or the second things. Next class, I've got also one for nested lists. That's got to be a whole lot of fun, because you can imagine how difficult I can make these things. Okay, so I checked these ones. They should all have correct answers this time. They are challenging because there's only 1 minute each. Okay, one person will start. So is it possible to get rid of people I don't like if you pick an inappropriate name? Ah, I can remove. Excellent. Yeah. Sure.
I know I'm not supposed to use one letter variables, but if I have something like weight in a function and then I want a similar variable, can I use W to refer back to weight?
You could get away with that in some context. I would have to see the program to know for sure.
Yeah.
Like for example, if you had a bunch of weights and you wanted to iterate through a list of them, I'd be okay using W for weight because it's only this big.
Yeah.
And if you have a function and it's a parameter and it's really well defined that the first parameter is right, I would probably allow it. Okay. But you have to talk to the person who's actually giving you a grade. So you can't use my comments as to say, hey, you took away a mark and he wouldn't have done it. Okay, so 25, that's usually about how many we have. And we lost one. Okay, one more second. 23. Oh, we're losing many. Okay, blame it on the Wi-Fi. Okay, 24. If we get to 25, okay, start. Oh, 26. Excellent. Last second. Okay, here we go. So, the more challenging lists, as if the previous one wasn't challenging enough. Oh, you see, it's only 4 lines. How hard can it be? Of course, those are spaces between, so it's like 6 and 4, not 64. Okay, so how do we do? Oh, again, people are going after the wrong one. More people went after 10 and 1 for some reason. Okay, well, let's take a look and see if we can find out why. All right, so we have an array called D and an array called F. Okay, D has 6 elements and F has 4 elements. And what we do is we take F and we append it at D. Now, remember, when you append a list onto a list, you end up with a list at the very last element. Okay, you don't end up with a adding 4 new items to your original list. You end up with a nested list. So when you ask for the length of D, it's actually going to be 6. Okay, and the length of the very last element is going to be 4 because there's 4 ones. Okay. So pop, reverse, pop, that is, and then like this. And pretty simple as X plus Y. Oh, and don't you hate it when the instructor gives you like runtime error? It kind of goes along like none of the above. And the word none doesn't mean none of the above. It means it actually prints the value none on the screen. We've talked about nuns before. Oh, it's going to be a lot of answers coming in the last second, I think. Which means they're mostly guesses. Oh, okay, good. More people got it correct than incorrect, although there seemed like there was a bit of guessing. All right, so remember, when you call pop, that gets rid of the last element, but it also returns it. Okay, so you not only get it, but you also pick it. So the value of X will have the number 7. 7. Pop always removes the last element unless you say otherwise. All right, the next one up, D dot reverse. Okay, ooh, sorry. I think that might be one of those things I should have included in the first slide. It's not a big surprise. D dot reverse actually takes the entire list and flips it around backwards. Okay, so if you flip the entire thing around backwards, it means that your list would contain 2, -1, 10, 3, and 5 in that order. Pop at 0 gives you the very first element, 2. And 2 plus 7 is 9. That's why 9 is here. Yeah.
Suppose
supposed to say D equals the D dot reverse, or just
No, just D dot reverse. Okay. Actually, if you said D is equal to D dot reverse, line number 4 would blow up because you would get back none, and you can't pop none. Yeah, there's a couple of functions like this. It's like the sort function, so it isn't D dot sort. It's just, or sorry, D is equal to D dot sort. It's just D dot sort. The same is true here with D dot reverse. It actually flips it around in place. Okay, but interesting thing to point out, because there are other languages like I think in there's a bunch of functions that we have in my Web Tech 2 class that you actually have to reassign it afterwards. Okay, so good. I mean, at least more people got it correct, even though you didn't see what the maybe you didn't know what the reverse was. At least it was pretty obvious. Okay, so next one. Okay, so there you go. There's a sort, and there's no strings. That's at least good. So there's no tricks. Of course, there's no tricks. There's at least 2 tricks in here. Okay, let's see how we do. Yeah, okay, maybe not that good this time. Okay, runtime error. Okay, let's try to look through and see what actually happens. All right, D starts off, we've got this array, it's got 6 elements from 5 up to 7 with a bunch of stuff in the middle. Line number 2, we create an alias called W. So remember, whatever we're doing to D, we're also doing to W, and whatever we do to W, we're also doing to D. So very, very important. So when we call D.sort, W is also sorted. Okay, so W will be -1, 2, 3, 5, 7, 10. Exactly in that order if you were to print it. All right, now we go into a range. Okay, it says for V in range 4. Okay, so V will have values 0, 1, 2, and 3. All right, and then what we do is we remove the individual items. So the first thing that we do is we try to remove 0. Is 0 inside my list? And the answer is no. When you try to remove something that doesn't exist in a list, you get a runtime error. So it doesn't ignore it, it actually causes a runtime error, which means we don't need to go any further. Yeah.
Remove function. We both inside the index or the value we want.
The value. Yeah. If you want to provide the index to remove something, the operation is called pop. Okay, so that's a difference. And pop would work perfectly fine here. Okay, that would pop 0, then 1. It would be very difficult to trace because it would remove the 0, then remove the first element after you've popped it from before. So you'd actually be removing the next one. Very, very tricky stuff. I should have had a function like this. But the remove actually tries to remove a value, but you have to make sure it's there first. Okay, so yeah, that one can be a bit of a surprise. Okay, so on to the next one. What are we doing? Okay, good. What was I thinking? 9 lines like this? I should have given less time, like 15 seconds or something. Well, good job. More people got that correct than otherwise. Okay. take a quick look at it. Okay, of course, we're printing out the length of W. Okay, W was a copy of D, so anything we're doing to D, just completely ignore it as a distractor. All right, so D contains 1, 2, 3, 4, 5, 6 elements to begin with. Okay, that's fine. Ignore, okay, well, W contains this. Okay, ignore this, ignore this, ignore this. It flips it around. I don't think it really matters. And what it does is it then calls pop 3 times. So drop the last element 3 times. So the last 3 elements will disappear, which means that 4, 6, and 1 will disappear because it has been reversed. Okay, but that's not even that important because eventually we're just interested in the length, and then we call extend. Extend is different than append. Append would take the list and stick it at the end. Extend, on the other hand, takes the 2 lists and merge them together into a slightly longer list. So although we remove 3 elements, we put 3 elements back. And as a result, that's why we ended up with 6. Okay, one more. And the next one is just in the spirit of trying to prevent your neighbor from saying, hey, it's a red circle. Okay. This is just for fun. It should only take a few seconds and we'll be done. Because if somebody says, hey, it's a green square, it's like, okay, other than a bunch of people went for slightly the wrong one. Okay, so we're talking green square. Okay, like the answer green square. All right, so we pick up D has got this array, and V becomes the very last element, which is a green square. We append another green square at the end, but then we print out V at position 0. But of course, that's the value at the position, not the array. Or not the list at position 0, because that's the original value that we picked out. Okay, there you go. All right, so as usual, caught a bunch of people. Hey, yeah, the problems I put on the test are never quite this challenging, but hey, at least we have these as sort of for fun. And usually what we have is easier, but you can see where you can get caught up on things. Okay, see you next class. Nothing. You get to leave. That's the reward. We're done. And here. Just give me a second.